Well, this will be a little different. Um, this is what I call the EE lab. It's a table, and all I have is digital stuff on it. All the other stuff, the CAD and the 3D printing and the fabrication and the testing and the cutting and all that, and the layout is way over there. So this is another spot that I work in. And what we're doing is, with the consideration of the new engine and this space and some other things, we're exploring the use of microcontrollers. And what I have is sort of a little demonstration kit that I have had for a while, but never really got too much into it. I wasn't sure what I was going to do. And then I also have two individual controllers, each with their own power supply, so they're not connected in any way. And then here's our plan of action, the engine side and the tender side. And the controller in the engine would sit here and would have a network going out, power coming in through the transformer. Then the signals will be coming out of here and going up into the engine to run the motor, looking at running the smoke and potentially the chuff and the sounds, and putting a speaker in both, a speaker in the engine, a speaker in the tender, so you could do the chuff sound constant, and then on the tender side you could have the whistle and the bell. And I'm going to be looking at other things like station announcements and cab engine, fireman and engineer chatter. What we're going to be trying to do today, what we just finished, was sort of monumental. This little black spot here and the black up here, and this one has one as well underneath there, that's an antenna. So these guys are using a local area network of its own through those antenna. This is going to be a base control. This is the one you would have where your transformer was sitting, and you may or may not have it in a little box, or it may be on a PC. We don't know yet for sure. Well, you can do all of those, okay. But the test today was, we're going to send a message from this guy to blink that red light. And then we're going to switch it to blink this red light. So these red lights are going to be blinking left, right, left, right. And every time it blinks, the main one is going to blink once. So all we're trying to do is say, can you tell him something? And then you tell him something, and then you tell him something, you tell him something. And can we verify that you're doing that? That's all I'm doing. This is, for me, Dennis 101 question. Can this stuff do it? Now, from that, we're going to move on to controlling the motors and everything else. Got some engines here. I got a DC can for test, and I got an old 3D printed chassis that does have a flyer motor with DC fields. So they're DC motors. One's the open frame, one's the DC can. And we'll be testing that. Hopefully this afternoon we'll get that ironed out and working, and we'll be able to see. And then we can move on. Okay, now we can send a message and get it back. We see that. Now let's try to build the circuits, build out these circuits where you have a motor controller board, a sound board, and some other devices, maybe LEDs. And let's see how we can control these two engines this way, wirelessly. So this board and some other stuff would go in the tender and the engine both. And this guy would be sitting at your control panel near your transformer. And you would use something, and this is just an experiment, okay? It's not the real deal. I have other concepts of what that would look like, but it could be a small handheld, it could be your cell phone, it could be an iPad. This thing actually operates in the Wi-Fi, so it has an internet. You can go to an address on your local area network and use buttons on your screen of your phone to control the engine. And you select which engine 1, engine 2, 3, whatever. And then you move it. Now, we're still ironing out all the operational stuff, but this is what I want to be able to put in this new chassis and revise the tender so it's updated with this type of control. So it'll be a microprocessor or microcontroller controlled environment, which is software. So where we had the puff and chuff board and all that wiring and all those sensors, it's gone, literally gone. What we can do is put a counter in that computer here, a sensor and a counter. Is the motor running? No. Turn the smoke to idle. Okay. So now you got the low speed idle smoke. I don't need to have a sensor. I don't need, this guy is running the show. He knows what's happening. He knows when we're in idle. And then he tells the fan on the smoke to blow slow. Okay. He also gets a trigger input to say, chuff, full speed now, now, and goes on. So he does that. If there's no motor, there's no chuff, then you go to idle. So the logic is going to be identical. But all of the functionality, instead of sensors and cams and wires and switches and PC boards and all kinds of paraphernalia, it's going to be a microcontroller and software. Okay. This is your introduction to Open Next Generation S Level 2 controllers. We're in the process of building it. Just showing you this right now to get you warmed up. Get feedback. You see it, you got questions, ask them. You got ideas, tell me. You want to participate, let me know that. We'll be building prototypes and letting people try it probably. So let us know what you think and how you feel. I've decided to keep this engine pretty much as is for myself, and I'm going to build a new one. It'll be a Beta 3 with all of the tweaks and all the changes that I need to make on that one. I'll put them all in the new one. But there's no reason for me to disassemble that because everything on it is not going to be the same. So why it runs beautifully. It's my first one. Let's archive it. I have my first smoke, my first puff and chuff, my first 3D printed 8-wheel chassis. So let's stack them up, look them at them, start a museum. Okay, that's where we are. I'll chat with you later when I have more to say and give you a little more show and tell. Okay, later.